For today's Do Now, I want you to answer these three questions. So number one, you're just thinking about the prefixes for all of your different numbers of carbons when they're all single bonded together, so the alkanes. Number two, you're drawing a structure. So you can pick whether you want to draw the bond line or the condensed structure. And then number three, I want you to take a look at that compound and see if you can name that compound. So take just a minute, pause the video, and then work through these questions. Play the video once you are ready to go over the answers. So let's take a look at the answers to the Do Now for today. So question one is asking for the name of a 3-carbon chain with all single bonds. So this is just knowing the names of all of your prefixes for alkanes, because if it's a single bond, it ends in ANE. And so if it's 3 carbons in a straight chain, it doesn't say anything about any substituents. Remember that prop is the prefix for 3 carbons, and since they're all single bonded together, it's going to be propane. For number 2, it wants us to draw the structure for 2-iodo 4-methyl octane. So I'm going to put just a line down the middle. I'm going to show both the bond line and the condensed structure. So whether you want to show the bond line or the condensed structure, you'll be able to see both ways. So I'm going to start by doing the bond line structure on the left. So we have 2-iodo 4-methyl octane. Remember, we always start with the end of the name first. Octane means 8 carbons. So I need to make sure that I show the longest chain with 8 carbons, and ANE means it's all single bonds. So remember, as soon as your pencil hits the paper, that's 1 carbon. So 1, 2, 3, 4, 5, 6, 7, 8. And just to double check, I'm going to number the carbons. I'm going to start from the left and number across to the right. You could start the other way as long as you put your substituents on the correct carbons. So I'm going to go ahead 1, 2, 3, 4, 5, 6, 7, 8. Number those carbons. Now off of the second carbon, there's an iodo substituent. Iodo just means there's an iodine. And off of the fourth carbon, there's a methyl group. Remember, methyl is 1 carbon, so we should see a CH3 group. So off of carbon 2, we're going to see a single bond to an iodine. And off of carbon 4, we see a single bond. We don't put anything at the end because remember, these bond line structures show the C's and these bond line structures show the carbon skeleton. So we only show atoms that are not carbon and hydrogens only if they're attached to atoms other than C. So now for the condensed structure, let's start the same way. So let's start by showing 8 carbons. 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7, 8. So now off of carbon 2, 1, 2, I'm going to show a single bond to iodine. Now whether you draw it on the top or the bottom, it doesn't matter. And then off of the fourth, 1, 2, 3, 4, I'm going to show a CH3. Remember, you need to make sure that your carbon is single bonded to carbon. Don't show it attached to an H, show it attached to the C. Now, those are the only 2 substituents, so we fill everything else in with H's. So this carbon only has 1 bond, it needs 3 more, so it's going to have 3 H's. And we go through and fill. This has 3 bonds, needs 1 more. And then we're going to have CH2. This is a CH, CH2, 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 CH3. So there's the condensed structure, there's the bond line structure. Either way you show it is okay. If they don't specify, you pick whichever one works best for you. Then number 3, it wants us to name this structure. The first thing we need to do is find the longest chain. So I'm going to start from the left and just count different ways. 1, 2, 3, 4, 5. Remember, this is a Cl, that doesn't count as a C. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So the longest chain is 6 carbons. Now, whichever way you decide to go up at the top, it doesn't actually matter. So I'm just going to go ahead and in pink, just show the longest chain that I'm going to focus on, just so it helps us as we number. So I'm going to follow that chain. Now remember, when you start numbering, you want to make sure that you number your carbons so that it gives the lowest numbers for the substituents possible. So if I start on the left side, 1, 2, 3, 4, 5. So I'm going to have a substituent at 2, 4, and 5. If I go the other way, 1, 2, 3, 4, 5. So 2, 3, and 5. So 2, 3, and 5 are the lower numbers. So I'm going to count this way. 1, 2, 3, 4, 5. And then 6. So the longest chain is hexane. So at the end of the name, we should have hexane. And then we just look at all of our substituents. So I'm going to go ahead and circle all of our substituents to help us name. So I see that off of carbon 2 and 3, we have methyl groups. So since we have 2 of them, we should see dimethyl. We have a chloro group, and we have a bromo group. So remember, these need to be in alphabetical, not numeric order. So alphabetical means I'm starting with bromo. So I'm going to have 5 bromo at the beginning. So 5 bromo. You use dashes to separate numbers and letters. After B, we're going to come to chloro. 5 bromo, 3 chloro. And then because we have 2 methyl groups, we're going to have 2, 3 dimethyl hexane. So I had to kind of squeeze it in there. So 5 bromo, 3 chloro, 2, 3 dimethyl hexane. Remember, the D doesn't count in alphabetizing, the M does for methyl.